All right, we're back. We're still on page 180. We're talking about taking plane curves, the graphs of the component functions, and turning it into the plane curve. And we found out, or I told you, because we didn't really do it yet, that if the component functions are piecewise linear, then the plane curve is also going to be piecewise linear. And that's a really big important fact that is useful to know. So let's see if we can do one more. So we don't have a table. Do we need a table? If we need a table, we'll make a table. I think we don't necessarily need one because when t is 0, we can see that x, well, let's label these up. This is the x-axis. This is the t-axis. This is the y-axis. This is the t-axis. It's really important to keep track of that because it's always like, what's a function of what? What are the independent variables? T is the independent variable. It is the parameter. It determines the values of x and of y. Both of these are piecewise linear, so the end result is also going to be piecewise linear. So let's see if we can do it. So when t is equal to 0, we get 0 and 0. So let's put a point there, and we could label it as t equals 0. Now, we have to do each important thing. So there's nothing really interesting happening on the x graph between 0 and 3. So t equals 0 to t equals 3, nothing interesting on x. But on y, there are interesting things. It keeps changing. Right? So when t is equal to 1, y is equal to 1, and then it's going to change. So we need to consider that point. So when t is equal to 1, x is actually 1, y is 1, so 1, 1 it is. That's when t equals 1. I'm not going to do anything there. I think we'll be able to put an orientation on this. I'm not really sure. So that's when t, well, maybe I'll label it. All right, t equals 2 is another interesting point here. It's not really interesting here, but because it's interesting for y, it's also interesting for x. It's one of the, it's like when you're in a partnership, what's interesting to one is interesting to the other. You have to like have that give and take. So when t is 2, x is 2 and y is 4. So 2, 4. Got like an exponential thing going here. So t equals 2. When t is equal to 3, t equals 3 is interesting for both of them, there and there. So x is 3, y is 9. X is 3, y is 9. That's when t equals 3. When t is equal to 4 is interesting for y. It's also interesting for x. So it's going to be 0. Wow, that's a big change in x. So we get to 0, 7, 0, 7. That's up here. So that's t equals 4. You don't have to label each time. I mean, I'm going to keep saying you don't have to and keep doing it, but whatever. T equals 5 is interesting for both. So that's 2 and 4. 2, 4. Well, this is interesting. Okay, so we're going to get back here again at t equals 5. So we're at that point twice. It becomes very difficult to put in your orientation when you intersect the same point twice. When t equals 6, x is 1. No, it isn't. When t equals 6, x is 0 and y is 0. 0, 0. Back at the origin. So we're here at both of those. So what do you look like here? So it's got to be piecewise linear here. Oh no. Get in there. There we go. Then we're going to go up here. Then we go over here. Then we go here. And then we go here. All right. So I put in all the times because it's like really difficult to put an orientation on this curve, which is not uncommon. I will say people, depending on what you grew up watching, a lot of people think this kind of looks like Phineas and or Ferb. I don't know which. One of them, kind of, maybe. I don't know. Or like there's like a mouth here, perhaps. Something like that. I don't know. Sometimes I think it looks like a guy wearing or girl wearing like I don't know, some sort of a thing, a scarf, I guess, or a tie, perhaps, depending, like blowing in the breeze, whatever. I like to imagine that my figures are things. But anyway, I think we're making good progress. I recommend you like play around with GeoGebra, make up some of your own perhaps, like on paper, and see if you can convert your piecewise linears into other things. Google search or whatever you like to search with. For interesting parametric graphs, I think you'll find a lot of those because a lot of like the intersection of math and art, there's a lot of parametric equation type things. Anyway, I will be back in the next video and we'll keep learning more so that you can do more. So I will see you there.